Hello everyone, here's Unit 13, Lesson 2, Arc Length and Area of a Sector. Do now, given circle C, which means C is the center, and C is equal to 5. Well, if then CA is also equal to 5, because all radii of the same circle are congruent. It also means that a diameter 5 plus 5, or 10 units long. So then they ask us to find the circumference of the circle in terms of pi, which means pi is in your answer. So if you go back to your formula sheet, the New York State formula sheet here, you'll see that the area of a circle is given, and also the circumference. And circumference is equal pi times the diameter, or circumference equals 2 times pi times the radius, because 2 times the radius would give you the diameter times pi. So it's really the same formula. You can use either one, whichever one you feel most comfortable with. I'm actually going to use, get the circumference is equal to pi, sorry about that, times the diameter. All right, so it says the circumference of the circle. So the circumference equals pi, and we already talked about the diameter being the entire length of from point A to point B going through the center C. So it's going to be pi times 10, and we write that as 10 pi. Now it says find the length of arc AB in terms of pi. So once again, arc AB is going to be equal to half of the circle. So we're going to take half of the circumference, okay? So we're going to simply just do half of 10 pi. So the length of arc AB is equal to 5 pi. Now we're going to find the area of terms of pi. So again, if you go back to your formula sheet, it's not a formula that you need to memorize. All right, it's the area of a circle at capital A is equal to pi r squared. So area equals pi times the radius squared. So again, in terms of pi means pi is in your answer. So it's pi times the radius, which is 5, and then we're going to square that. So the area equals 5 times 5 is 25 times pi, that's our area. Now it says find the area of the semicircle in terms of pi. All right, so we're going to find, so it's like the area rug, right? We're going to find the area, so this piece here of the semicircle. So the area of the semicircle is going to be, once again, half of the circle, right? A semicircle means half of the circle. So now we're going to take 1/2 of the area. So 1/2 of 25 times pi, and that is equal to 12.5 pi, and that's equal to the area of the semicircle. And here's a vocabulary. We're going to talk about the arc length, the circular distance around the arc. So the length of the arc is the fractional part of the circumference of the circle. So what does that mean? It means that you're going to take the central angle, and you're going to divide it by 360. So when we're looking for the arc length, so remember, every circle is a different size, right? So like this circle had a radius of 5, this circle might have a radius of 4, this circle might have a radius of 3, or maybe 10 or 12. So a circle can be bigger or smaller, so the arc length is going to be different. So that's what we're going to find in this lesson. So you're going to take the central angle, which is equal to the arc, divided by 360. That's the fractional part that they're talking about. And you're going to simply multiply that by the circumference. And the circumference of a circle we just talked about to be pi times the diameter. So that's where that formula is coming from. So some of you might think of icing on the cake, right? It's the outside part of your figure. When they talk about the sector, it's the region formed by 2 radii and the arc of the circle. So here's going to be your sector. It's formed by 2 radii and the arc. Okay, so it's going to be this part here. So the area of the sector is going to be the fractional part of the area of the circle. So the fractional part is going to be, again, that central angle which is equal to the intercepted arc, divided by 360. So which part of the circle, right? A circle is 360 degrees. Which part of that times the area? And we just talked about the area formula to be pi r squared. Okay, so we're just going to use multiplication there. So maybe this one you want to think of having a piece of the cake. Piece of the cake. Okay, so when we talk about the arc length, we're talking about the outside. When we talk about the area, we're talking about the whole entire piece. And here are those formulas we just talked about. The arc length, right? The icing on the cake, the outside is going to be the measure of the central angle divided by 360. So the fractional part times the circumference. And the area of the sector is going to be, again, that central angle divided by 360, the fractional part times the actual area. So here it says given circle O, so what do we know right away? O is the center. The radius is 15 centimeters. Well, if one radius is 15 centimeters, here's another radius. This is also 15 centimeters. We also know that the diameter is going to be 15 plus 15, which is going to be 30 centimeters. And the measure of angle PO, O is the center, POR, that makes this a central angle, is going to be equal to its intercepted arc. So this arc is also 120 degrees. So now it says find the arc length. Well, here's the formula. We're going to take the measure of the central angle, 120 degrees, divided by 360, that's the fractional part we talked about, times pi, times the diameter, which in this case we said was 30. And now it says in terms of pi, so don't put pi into your calculator. So what I did is I took the 120 divided by 360, and I took that answer times 30, and I got 10. So our answer, the arc length, is going to equal 10 pi. And now you're going to do the same thing for area of the sector. We're going to start out with the central angle, which once again, it's still 120 degrees, divided by 360. But now we're going to talk about the area. So we're going to multiply that by the area formula, pi r squared. So now we're going to take 120 over 360 times pi times the radius, which in this case is 15 squared. And once again, you're going to plug that into your formula, but not pi. Pi will be in your answer. And I plug that into the calculator. 120 divided by 360, that's the fractional part of the circle, times the 15 squared, comes out to be 75. And remember, pi is in your answer. So your answer is 75 pi. And that's it. That's how easy this is. You just need to know that these two formulas right there. Arc length is the fractional part times the circumference, and area of the sector is the fractional part times the area of a circle. Example number 2, given circle O, which means O is the center. So when they tell you OQ is 5 centimeters, then all the radii of that circle are also 5 centimeters. So OP is also 5 centimeters. And also, while we're here, let's talk about the diameter. The diameter is going to be 2 radii added together. So the diameter will be 10 centimeters. And arc PQ is 72. Well, if arc PQ is 72 degrees, then lead that back to the angle, happen to be a central angle. The central angle is equal to the intercepted arc. So when it says find the arc length of PQ, we're going to go back to that formula. We're going to take the central angle divided by 360, that's a fractional part of the circle, and multiply it by the circumference. So in this case, it's 72 divided by 360 times pi times the diameter, which we said was 5 plus 5, or 10. And now it says determine the following to the nearest tenth. So this time we're actually going to put pi into our calculator. So here's in the calculator, I did 72, the central angle, divided by 360, and I multiplied that answer times 10 pi, the circumference. It came out to be 6.28. We're rounding to the 10th place, so we look at the next number, and since it's 5 or more, that 2 becomes a 3. So 6.3, and if you like to use unit of measures, it's centimeters. Now we're looking for the area of the sector POQ. So it's the central angle, 72 degrees, divided by 360, that's the fractional part, times the area, pi times 5 squared. And once again, we're rounding to the nearest tenth, so put pi in the calculator. And once again, here's the math. 72 divided by 360 times the area. 5 squared times pi comes out to be 15.70. We're rounding to the 10th place. And since the number after 7 is less than 5, our final answer is 15.7 centimeters squared. Great job. Meet you on the next page. Example number 3. Diagram below shows circle O, which means O is the center, with radii OA and OB. Well, what do we know about all radii of the same circle? They are congruent. So if one section of the radii is 6, then so is OA. The measure of angle AOB, notice O is the middle initial, so that's the center of the circle. That makes this a central angle. Central angle is equal to its intercepted arc, is 120, so therefore arc AB is also 120 degrees. The length of the radius is 6 inches, so therefore all the radii are 6 inches, which expression represents the length of the arc AB in inches. So you're going to go back to that arc length formula. Arc length is equal to the measure of the central angle over 360. That's a fractional part of the circle. And in this case, we want the length of the arc, so we're talking about the circumference. So the central angle is 120 over 360. We're multiplying that by pi times the diameter. Well, if a radius is 6, then the diameter is going to be double that. 6 plus 6, which is 12. So now we're going to, this is multiple choice. I don't see that as one of my answers, right? We have 120 over 360. That's correct, but the 6 times pi is incorrect. 120 times 6, that's wrong. Let's see, what is 120 divided by 360 reduced to? So 120 divided by 360 comes out to be 0.33. If I hit math, enter, enter, oh, that actually reduces to 1/3. So this is actually 1/3 times 12 pi. So it's not choice 3, it's actually choice 4. Excellent job. Look at example number 4. Given circle A, so what do you know? A is the center. With a radius of 12, well, if the radius is 12, what's going to be the diameter? 2 times 12, or 24 centimeters. And the measure of angle CAB is 30 degrees. Well, that's a central angle, which means the arc is also 30 degrees. Determine the following in terms of pi. So this time, do not put pi into your calculator. They want the arc length and they want the area of the sector. So it's the section of the circle times the circumference and the fractional part of the circle times the area. Start out with the formulas. And once you have the formulas, it's just plugging it in. So the central angle is 30 degrees. Out of 360, you're multiplying that by pi times the diameter of 24. So 30 divided by 360. And then you're going to multiply that by 24. And you're not putting pi in the calculator, so it comes out to be 2 pi. And the next one is 30 divided by 360. Again, it starts out the same, but this time we're talking about the area. So it's pi times 12 squared. So 30 divided by 360, multiply that by 12 squared, it comes out to be 12. So the answer for this one is 12 pi. Fantastic. All right, so what I'm going to do is I'm going to stop the video here, and I am going to meet you in part 2 of the next video with example number 5.